From 5G networks to aerospace systems, from artificial intelligence to quantum technologies, from behind the scenes of innovations to real-world applications. Welcome to Innovations Unplugged, the Rohde Schwarz technology podcast. I'm Inga Müller-Siedentop.
And I am Markus Haller. Today we talk about something you use every single day. When you sit on your sofa, when you take a coffee in your favorite coffee shop, on a train, or when you are at the airport waiting for boarding time. Today we talk about Wi-Fi, and specifically about Wi-Fi 8. Not standardized fully yet, but it is already making waves at Mobile World Congress 2026, the leading trade show for the mobile communications industry. And today we ask, what is new in Wi-Fi 8 and why does it matter to all of us?
To explore that, we've invited a guest who's been living and breathing wireless for over 2 decades, Günther Pfeiffer, product manager for wireless LAN signaling at Rohde Schwarz. Welcome, Günther.
Hello, thank you. Nice to be here.
Günther, first things first. We talk about Wi-Fi. Your role says wireless LAN signaling. Help me out. What's Wi-Fi versus wireless LAN?
Very good question. This is where I would say everybody, first of all, struggles. Why do we have different terms for the same thing? The standard, the technology that we are talking about is called wireless LAN, right?
Okay.
So it's like LAN, but over radiated. The standard body is IEEE. Mm-hmm. And they standardize this, or they specify how wireless LAN should work, and they call it wireless LAN. Mm-hmm. Now, once it's rolled out into the industry, there is an industry consortium called Wi-Fi Alliance,
Okay.
And that was starting more or less at the same time when wireless LAN started, or the first specifications came out, and they said, okay, this is too complicated. IEEE 802.11 something. Mm-hmm. Nobody understands that. Mm-hmm. Nobody can memorize that. So they started to build a brand name and they called it Wi-Fi, which is like an artificial word made out of hi-fi and wireless. Sounds cool, created by some marketing companies, and they called it Wi-Fi.
When standards and specifications come from the IEEE, why do we need another consortium?
So the specification describes how the technology should work.
Yes.
And then everybody starts implementing in the industry. Okay. And then there is room for interpretation. At one point, you will want to make sure that your Wi-Fi device of type A works with your Wi-Fi access point of brand B. And this interoperability needs to be tested and needs to be ensured. And there is this industry consortium, Wi-Fi Alliance, that does exactly that as a focus point.
Last question on that one. You mentioned it came up, the Wi-Fi Alliance was built when Wi-Fi came up, pretty close. Which time are we talking about?
Yeah, it's more than 25, actually, 27 years, you can say. It was just before the millennium, when the first Wi-Fi standards came out and the first Wi-Fi devices were built on top of that. And Wi-Fi Alliance was, I think, founded in 1999. Okay. And this is also about the time when we started almost with our test equipment on Wi-Fi.
At the end of 2025, there are more than 21 billion connected IoT devices, and their primary method of connectivity is Wi-Fi. So that means the majority of wireless data traffic is transmitted by Wi-Fi. Very staggering and actually surprising, at least to me.
Topic: video calls, browsing, online banking. A lot of people assume it's my Wi-Fi connection at home. And it must be a cellular network connection like 5G, for example, everywhere else. But in reality, most of that traffic also rides on Wi-Fi at home as well as in offices, hotels, schools, and even in cars and trains via onboard routers. Günther, can you share some facts and figures first on the global Wi-Fi coverage, Wi-Fi data traffic? What are we talking about in numbers?
As you said, there is about 20 billion devices that are used today worldwide in Wi-Fi. Yeah. It is way more than any cellular standard, or maybe probably even way more than all the cellular standards together. There is about 4 billion Wi-Fi devices shipped every single year. In total, there is, I think, 45 billion Wi-Fi devices that have ever shipped. And I would say, roughly speaking, 70-80% of the traffic goes over Wi-Fi, even if you're mobile. And what I mean with that is your day starts, you take your phone, you check your emails, whatever, in your house while you have breakfast. It's Wi-Fi. Then you leave your house and then it's cellular. But only as long as you're walking to your car, because if you have a modern car, you have Wi-Fi in the car. And that's, of course, then backhaul connected over cellular, but still you're using actually Wi-Fi. You are then moving to, say, the train station. I come by train every day. So train station, you get in the train, it's Wi-Fi. So your say the last mile, your connection, that the user terminal that you currently use to browse the internet is connected is Wi-Fi. And the backhaul, so how does this terminal connect to the internet? This is then an overlay, and this is cellular.
When we broaden up the horizon and talk about industry applications, just name a few like basic examples. What to imagine? What is Wi-Fi connected?
There is a huge number of different devices, machines, monitoring devices. Think about a hospital or surveillance cameras. Of course, your laptop, your tablet. Your normal communication devices. Sensors of all types, water meters, if you like, or electricity meters.
Where did we come from and how are we today?
Yeah, okay, that's a very good point. Think about it. I'm not sure for the audience, depends how long you are in business, but I'm in business since quite a while. And I remember when I moved into my current house, I bought an ISDN phone system. I had to unplug my phone. I had to plug in a modem that I slotted into my laptop. Today, you open your laptop, and before you even know it, it's connected and the emails are replicated because you have the data rate and you have the infrastructure. And you have it everywhere, as mentioned before, and it's all compatible. And that's maybe another important point for Wi-Fi, because you said before, what are the devices? These devices that you use in Wi-Fi have a different age. So they were introduced at a point when a certain Wi-Fi technology existed, right? But today the Wi-Fi technology has evolved, and you don't want to buy a new fridge just because you have a new router. This backward compatibility to all the latest from all the latest standards to all the old standards in the same
legacy
in the same
right?
Exactly in that same network and that same technology. This is a key for Wi-Fi, and that doesn't exist in cellular, for example. And we're talking about, in the very first one, data rates in the range of 10 megabits per second. Compared to my ISDN times, that was awesome, right? So 28.8 kilobits compared to 11 megabits. Yeah. Those numbers, though, are not necessarily the data rate that you get as an end user. These are the theoretical physical layer data rates. At the end of the day, you always have to deduct some. However, not every generation of Wi-Fi necessarily increased the data rate, but some did. And with the current latest version of Wi-Fi 7 that is now available, and you can go and buy a router and have devices that support it, then we are talking about double-digit gigabits, so like 20 gigabits per second in the ballpark.
We tend to think, as you mentioned, the next generation of Wi-Fi automatically equals more speed, so to speak, for streaming and everything else what we are doing. Give us the fast debrief. Does that hold true when we talk about Wi-Fi 8?
It does not.
Thank you.
That was the fast debrief. It does not. while,
so what are they working on?
Yeah, good point. Reliability is the key. So every generation of Wi-Fi, every new revision of Wi-Fi communication standard has a certain headline, a certain major topic that it wants to address. And yes, a lot of times it's data rate, it's throughput. So over these last 3 generations of Wi-Fi, we made it efficient, we made it fast, so Wi-Fi 6 efficiency, Wi-Fi 7 speed, and now we make it reliable. That means I have a high possibility, a high potential of getting a connection and maintaining a connection, even in harsh environments, let's say. So situations where you cannot easily connect to your access point. Normally, you have like a router and there is a ton of users that want to get access. And you might have experienced this before, that if you get into a venue where you have Wi-Fi coverage, but you have not been connected to the network before, so your phone doesn't automatically select, because then you don't realize it, right? So you go into your phone, you want to connect to that network by pushing on that network, and you wait. This is a congestion situation. Okay. And
too many devices want to enter at the same time at the same location, one access point.
Private, we already talked about it. It's just frustration, right? It's just like, why can't I get on this network? But if you think about in industry applications, reliability can be extremely important, right? Or is actually extremely important. Imagine you have a factory and it's covered by Wi-Fi, and you have robots working in that factory, and they need data and they need to be controlled in a way, so they have a Wi-Fi connection, and that Wi-Fi connection is unreliable. What happens? The one robot's smashing the other one, or the one robot running against the wall or driving against the wall? Reliability is extremely important, besides all the other features that we covered before in other standards.
Let's talk about one elephant in the room. Günther, Wi-Fi operates on an unlicensed frequency band. Not just Wi-Fi 8, but Wi-Fi in general. Günther, fill us in. What does that mean?
That's another specialty to Wi-Fi, if you like, compared to cellular at least. And the reason is simple. So we do have different unlicensed bands in the frequency spectrum. That means everybody can use it. You do not need to acquire a license for using it. It's great because you can just go and buy a router and you don't need to worry about licenses or whatever and plug it in. I can do the same and you can also do the same. And then we all have a router and they all try to use that spectrum, and then we have interference situations. And if you think about, now I live somewhere in the countryside, but if you live in Hong Kong on a skyscraper with, 1,000 flats, then there is 1,000 routers and they all fight for the same spectrum. And that is, of course, a total different ballgame now.
My router has to share frequency spectrum with lots and lots of other Wi-Fi routers, but I guess also with things that are connected but not Wi-Fi, like my Bluetooth earplugs. How does Wi-Fi technology handle this situation?
This is really a difficult situation, and there is, of course, a solution to it. And you're right, it's not only other Wi-Fi devices, it's Bluetooth, it's your microwave oven that also uses the same bands and maybe emits some radiation, unwanted emission, of course, that creates noise. So how to tackle that? Let's just focus on Wi-Fi. If multiple devices want to use the channel, there is listen before talk protocol, basically. So they have to first sense whether the channel is clear, and when the channel is clear, then they can request a transmission and then utilize the channel. And everybody else has to stay silent in that period while somebody else is using it. And this is also why this high efficiency came in, so then you can handle multiple devices at the same time, so it's less weight.
But that is nothing new, right? So listen before talk principles were pretty early in the Wi-Fi evolution, right?
Yes, from day one, I would say, because this is imminent for getting a connection to work without collision, right? There's also this carrier sense multiple access collision avoidance scheme. This is, I think, a very technical term for the same thing, listen before talk. Sense the channel before you use it to avoid that you collide with the packets with somebody else and then everybody has to resend, so you're wasting basically bandwidth.
That was more the perspective on how many end users are dialing in, right? So when there are crowds trying to use an access point, it's too crowded, just to keep it simple. How about the other way around? When we talk about Hong Kong, you just mentioned everyone in this huge skyscraper has its own access point to send signals towards other devices.
Yeah, the dilemma is that if you have many access points, you will have a reuse of the same channel because you have more access points than channel, and everybody that uses the same channel like you're using is an interferer to you. So you have to try to keep the interference low. You have to mitigate that in a way. And there's different ways of doing that. Wi-Fi 8 comes with new ways of doing it. Up to now, you just reduce the power levels, for example. And this is local specifications or local regulatory requirements that tell you how much power your access point as well as your station can emit with.
So let's take a closer look on how to solve these challenges on the technical scope. As we just heard, it sounds a bit like the old days, talking about where we're coming from. Signals, politely waiting, their turn to access the channel, their turn to send signals. How do we move from polite but more unpredictable world to super predictable at all times under pressure? That is what we're talking about when we talk about reliability, right?
With that Hong Kong scenario, right? Many access points in a skyscraper. So how can we make sure those access points don't create a lot of interference to each other? By coordination. So these access points need to be aware of other access points using the same resource, for example, and coordinate their activities, their traffic, their power levels, their resource assignments, whatever, right? And there is a feature in Wi-Fi 8 that's called coordinated access points, right? And actually, again, there's more features under this headline of coordinated access points. You have to be situation aware, if you like, right? You have to know what is happening around you in order to select, for example, the band, the channel that you're using, the power level that you're using, and maybe also to change it dynamically depending on the change in your environment.
What we covered so far is the management of the whole system. Are there options? What is Wi-Fi 8 tackling to solve what we heard as challenges before?
There is other factors, of course, in respect to reliability. I have temperature sensors in my house that are Wi-Fi connected or in my garden. And this is a difficult connection situation, right? It's using 2.4 gigahertz and it's somewhere out in the garden. It can hardly reach my access point. Walls, windows, and just distance, right? So the signal attenuates, and maybe these sensors are like IoT sensors, right? They have to be cheap, so you don't have the latest and greatest and most powerful amplifiers and whatever in there because it's just all a matter of cost. Now, how can we increase reliability? Here we go again. Ultra-high reliability is what Wi-Fi 8 is called. How can we increase reliability in the connection to my temperature sensor out in my garden?
Just increase the transmission power. So this would be my approach.
Exactly, but regulatory requirements have to be fulfilled. So you are not allowed to transmit with more than, say, 100 milliwatt. This is not very much power. And now, how can you still do this?
Otherwise, just a quick recap here. Otherwise, spectrum monitoring experts, also covered by Rohde Schwarz Equipment and Solutions, would knock on your door asking what is happening when your radio frequency is like in chaos.
Exactly. If you're transmitting onto high power, the regulatory body might knock on your door and say you have to shut this down, right? So Wi-Fi 8, as I said, can use a different mechanism to assign these resources to that user. It's still a resource unit, but it's now distributed over the frequency band or over the bandwidth, and then it's called a distributed resource unit. And it sounds more complicated, but the advantage is I can now really transmit on a higher power without violating any limits, because what is important is the power spectral density. So how much power am I transmitting in a megahertz? And now here's the trick in Wi-Fi 8. If I have many resource units in that 1 megahertz, then every resource unit can transmit only on a lower power, because in total over this megahertz, this all sums up into a certain power spectral density. But if I have only 1 resource unit in that megahertz, that resource unit can transmit on a higher power without violating the power spectral density.
I see.
So now if I transmit on a higher power, I have a longer reach, right? So if you shout loud, the people further away can still hear you. Same thing. Higher power means further reach, means my temperature sensor in my garden all of a sudden can reach my access point, where today it barely can.
Take a closer look on the test and measurement side of it, because Rohde Schwarz is not producing routers or smartphone chip designs for Wi-Fi. We are on the test and measurement side for Wi-Fi. Fill us in. What does our toolbox look like?
Funny enough, if you like, we are actually producing a Wi-Fi access point. What are we doing? We are doing a test equipment that mimics to be an access point. So we are, if you like, developing an access point that sits inside our test equipment, because what we want to test is, say, your smartphone, right? It has a Wi-Fi chip in there, can create a Wi-Fi connection. Now it should create this Wi-Fi connection to us, and so we have to be the access point. So we are the access point. Your smartphone connects over Wi-Fi to our access point. So now we can see what happens on the air interface. How is this transmission looking like? So is the spectrum, what is the spectrum you occupy? How well is it modulated? How good is the receive sensitivity of your device? Can it decode what I'm sending? And so on and so on. These are the parameters we typically look at. And in order to get to that, we have to get onto this connection. And to make this happen, we are an access point. So if you like, I could use that instrument that I'm responsible for, CMAX 500, our Radiocom tester, and hook it up at home as my access point. It could even be Wi-Fi 8, which you cannot buy today, but I could have my first Wi-Fi 8 access point, backhaul it back onto my DSL line, and there we go. We have a Wi-Fi 8 access point. But we're talking about stuff that will be visible for general users in years to come. And we're testing it today. What are we testing against? Or who are the customers that first need it? These are the chipset makers. What is a chipset maker? Well, the Wi-Fi in your phone, for example, is not built by whoever built your phone, but they typically buy that chipset. Some do it themselves, but most people just buy the chipset from a company that is specialized in that. And they built this chipset very early in time so that you have time to integrate it and get stuff done on your device, on your phone in my example. So they have a very early demand for new technology, and these are our customers today.
A final question to you personally. How does it feel to see the future of Wi-Fi taking shape, and that as part of your daily work?
Yeah, it's awesome. This is why I love it. This is why I do it since so long. I really enjoy that job, whether it's Wi-Fi or any other of the radio technologies that we are testing in our tester. Being part of what everybody knows in a way, but nobody really knows how it works in detail, and how these new technologies evolve over time and shape, exactly as you say, what happens in the future. Being like ahead of the curve, being very early in touch with all these people, having these technical discussions, and seeing how this new idea of how we could make this work comes to life is inspiring to me. since I do this job, and I'm doing it since a number of years now, and I'm not getting tired of it yet.
Our episode on Wi-Fi 8. We saw why it matters, we saw what's hard, how can we solve it, and where is it all going. If you are on the Mobile World Congress 26, you can meet our team or just ask for Günther.
Yeah, I'll be there.
So subscribe to Innovations Unplugged wherever you listen and follow Rohde and Schwarz on LinkedIn for updates. Big thanks to our guest, Günther.
Thank you.
And of course, to all of our listeners for tuning in. See you next time, and don't forget to subscribe.